Andrew Lamb. I'm going to talk about accelerating queries on Apache Parquet with metadata stores and specialized indexes, a somewhat nerdy topic. This is a recap of a talk I gave in June of 2025 at the Data and AI Summit in San Francisco that only a small number of people could go. Those talks weren't recorded, but I think this was an important enough topic to record myself, so I'm doing that as a second presentation. So as I mentioned, I'm a staff engineer at Influx Data, and I am also the Apache DataFusion Project's PMC chair, and I'm on the Apache Arrow PMC. I've worked in a variety of databases and low-level system software and done a bunch of engineering leadership stuff too. But I'm mostly today going to talk about my favorite pet project, right? Or my favorite opinion, which is that you don't actually need new file formats, that Parquet is actually enough, and that with the right types of indexes, you can actually build very high performance Parquet processing pipelines. We don't need a new file format. Somewhat ironically, when I was giving this talk, there was another parallel track that was discussing new file formats, such as like Lance and Nimble and whatnot. But I still think I would like to try to convince you that you can do a lot more with Parquet than people currently realize. And of course, I'll show you how to do this with DataFusion, but it's more broadly applicable than just that. So the first question is, do we really need new formats? There's a steady drumbeat of news about how you need like open formats basically constrict your options as a system designer and that they're slower. And so you can always get sort of better performance if you have a customized file format, which is true if you have infinite engineering. But I'm going to try to basically argue this whole time that if you can push Parquet quite far. The other thing you've probably seen, right, is there's lots of cutting edge Dutch research. I say Dutch research because these papers are from CWI, which is one of the leading database research institutions. They go into this special sort of DuckDB file format. They made a big deal about that it was able to have all these cutting edge innovations, which are very cool, legitimately very cool at codings. But let's see how well does it, I want to show you some data about how well this actually works. So the thesis is you can do much better than Parquet with your custom file formats, right? One data point is you go look at ClickBench, which is an analytic data set, an analytic benchmark focused on sort of aggregations and filtering. The DuckDB guys, right, with access to the most cutting edge research available to database practitioners, even their custom file format is less than 2 times faster than DuckDB with Parquet, right? So this is the DuckDB with Parquet. This is DuckDB with their own proprietary file format, the same hardware, same software, and it's less than 2 times faster. Now, two is not terrible, right? Like that's a significant factor, but it's not a factor of 10. By the way, the same pattern applies to other custom file formats like with DataFusion, Parquet. The difference between Parquet and a specialized file format with Vortex is not as high as, even the delta between DuckDB and Parquet. By the way, these guys will get much better. We will make DataFusion better. That's a topic of a separate talk. I know how to get it back up here. It's nothing fundamental. It's just engineering work. But that's kind of the point. So, and I also wanted to point out, there's less than factor of 2 difference between Parquet and, like, let's say DuckDB's proprietary format. But the Parquet that's being used on ClickBench is a really crappy version that was written with a really old version of the C++ open source Parquet reader, right? You can see Parquet CVP. By the way, this is a great screenshots from a great web page by Zhang Ping, but it doesn't have sort of special structures that are included in most Parquet files that can accelerate the performance. So basically, it's crappy Parquet, and even with the really crappy Parquet, right, the cutting edge research is only 2x faster, right? So what does that tell you? Right, in my opinion, that tells you with some more engineering, you get Parquet quite a bit faster. And in fact, one of our contributors to DataFusion, Zhu, I'm sorry, actually tried this as a brief experiment. He just took the same ClickBench files and just rewrote them using DataFusion with the same content, but they get rewritten with the modern headers and column indexes. And actually, like, the performance on a bunch of the queries goes significantly faster, right? So again, I hope like my point of showing you all this is that for people who say Parquet is not fast enough, I say if you invest more engineering effort in it, you can get it quite a lot faster. And in fact, there's a lot more optimization opportunities than people realize. This is showing just using the built-in data structures, but I'm now going to talk about you can go even farther with not just the built-in stuff, but your own custom indexes. So to begin, I need to talk a little bit about how Parquet works, just to level set, so we can talk and go on from there. So as you might or might not remember, Parquet is a file format that has things called row groups and column chunks. In this case, what that means is that it stores tabular data, right? So it stores basically rows and columns. And so the way that Parquet would store a file like this that has 3 rows and a bunch of 3 columns and a bunch of rows is you take horizontal chunks of the rows and store them in things called row groups. And then the individual columns are stored in column chunks. And that would be done for as many horizontal strips as you want. And you can configure typically the size of those row groups depending on your writer settings. Now, by the way, this is called PAX in DB literature. We'll come back to that. PAX was the name of the paper that described this organizational style about 15, 20 years ago. Then typically the way you read Parquet is not just you divide the data up like that, but the way it's actually written onto disk is it's written into data pages, which are encoded and compressed. And then there's a footer at the end of the file that has a bunch of metadata which happens to be thrift encoded, that has a bunch of information about how to find the data pages, what the schema of the file was, and actually has some basic indexing structures, specifically these page offsets. There's min-max statistics. You can have Bloom filters. Technically speaking, some of this stuff is not directly in the footer, but it's often near there. And so the way you work on querying Parquet typically is in order to read the file, what you do is you take your query, the query engine will look at the predicates, consult the metadata, figure out how much of the individual file it needs, right? And typically, as I'll describe in quite a bit more detail later, there's a bunch of tips, tricks, and techniques that are used to quickly figure out which pages you need to read and basically which ones you can skip entirely. And a lot of that's based off what's in the metadata footer. And then the system will go and actually do the work for those pages. So that's like Parquet processing 101. And I'm going to talk about how you inject your own sort of custom indexes into here. So if you think about what the processing pipeline looks like for any query systems, this is DataFusion, but it basically is exactly the same for ClickBanch or DuckDB or any system. Is you typically have the data organized in a variety of, in like a hierarchy, maybe in files. And then within the file, they're organized by row groups and pages, like I just described with DataFusion. And then when you start querying, you actually go. So typically during query processing, the goal of making, the way you make queries fast is you really, really quickly figure out what not to do. And so the first thing you do typically is you prune that, you pick the subset of files you need. So that sort of pruning files, you do that on a catalog. We'll talk about that in just a second. And then there's 2 other levels, like within the file for Parquet specifically, you'd be able to potentially rule out entire row groups or entire data pages. And then in fact, when you're doing columnar scan, you can actually do fancier things like pushing the filter down and sort of do late materialization and apply filters to one column before you do that. But I'm not really going to talk about that too much in this talk. Maybe I'll talk about that in another one. So my point of sort of before we launch into the example with DataFusion is the point is, if you think about that high level processing pipeline, it's exactly the same for Parquet-based systems and other systems. Like, for example, like I said, pretty much all analytic systems have this PAX layout in the sense that they take horizontal chunks of the data. They all have some version of data pages, which is like the minimum decode unit. They all have some metadata that they use to quickly figure out which parts of that hierarchy to skip. For example, ClickHouse uses different terms, but they're basically, very, very similar concepts such as parts, granules, and indexes. The DuckDB file format has also the same basic concepts. Well, I think they actually literally call it row groups. And I don't know what maybe even data pages. But the only thing that's really different is where you put the metadata, right? Maybe it's in the file, maybe it's in some other auxiliary structure. Encodings actually also make a big difference, which I'm going to ignore on the assumption that we're going to get our act together in the Parquet community and add some new encodings. But that being aside, basically the conclusion here is that there's absolutely nothing that prevents you applying the same sort of tricks that are used in other database systems with this multi-level pruning on Parquet. Right. It's just a matter of software engineering. You need the right structures to do it. Obviously, DataFusion has them. Otherwise, I wouldn't be talking about this. But it's not really like DataFusion is just a good existence proof. There's no reason you can't do this with other systems as well. So I'm now going to go through 2 examples to talk about how to prune files and then prune subsections within a file using Parquet. So to remind you, the system we need to build is given predicates, right? Given filters on a query. which files in a pile of files that you might store do you need to scan for more processing. So some version of this happens in any analytic system. It doesn't have to be, maybe it's part, it happens in Parquet, it can happen in Parquet-based systems, but certainly in non-Parquet-based systems too. There's nothing Parquet specific about it. There's an example in DataFusion. I'll leave them the links to the video. It's called the Parquet index, but basically it shows how to take, predicates, refer to some index structure, which I'm going to sort of be vague about what that does, but like this is where the special sauce is. This can be all sorts of different things. And then configure DataFusion to only read files that the index determines might contain data that match the predicate. And it's really not that complicated, right? So this is Rust code. Hopefully it's not too intimidating. This is literally, I took the Parquet index example and I did simplify it a little bit, but not too much. This is still the basic idea. And so in this case, this is the table provider for DataFusion. So that's like the table interface. And what happens is if you run a query, eventually DataFusion will call the scan function that passes the state, which columns you need, that's the projection, and it passes the filters, right? So it handles all the filter push down for you. And so now your table provider, in this case, given the filters, right, you just have to figure out what files are needed to be read. Now I'm hand waving here, right? This can encapsulate all sorts of fancy optimizations. And I'll talk about some examples of them later. But that's basically the API, right? Given some filters, which files do I need to consult for more process? Do I need to actually read? Like that's it, right? So this has nothing to do with Parquet. But here's how you do it. If you did that, you get a list of Parquet files. Then here's some of the Rust code to actually sort of configure the builder to read them. It's basically mechanical. And then you get this sort of data source exec that just goes and scans those files really fast. So that's it, right? Like, you can build all sorts of crazy indexes that rule out files really fast with whatever you want there. Just to give you the specific example to make it concrete, right? Like that's a nice API, but it's also pretty abstract. A concrete example that's used in this example is, I think what we've done is it extracts the min-max values for some of the columns and stores them in a separate structure. So basically the query predicates come in and then you can consult this separate structure. I think it's in memory or something in the example, but in a real system, it could be whatever. But I'm trying to say that I've kind of waved over like, well, you get an arbitrary expression from a user and you've got to figure out which files might or might not match that, right? Like that's in general a pretty complex algorithm to figure out. One of the nice things about DataFusion is it includes the range analysis that you would need to use for minimum maximum values. So given minimum maximum values for columns, say, or files, and the predicate, DataFusion already includes the logic to do that analysis for you and tell you whether the file could possibly have a match, right? And handles arbitrary expressions. And this is the API. So you just have to feed the min-max to it. And again, it's all in the example. But I'm trying to show you like this, it doesn't have to have min-max values, right? You can put Bloom filters, you can make this a full text index, you can do whatever special thing is required for your system. And that's it, right? Like you just figure out the file, you pass it to the reader and it goes. It's really, pretty powerful. All right. So here's some examples of catalogs that I know about that use this. Obviously the system I work on, which is InfluxDB3. In our distributed version, we have a distributed catalog. So we actually store information about each file, the time, the min-max times, as you might imagine, because we're a time series database. Those are stored for each file in a Postgres database. And so when a query comes in, we can quickly use that time predicate in the input query to fetch only a small subset of the files from the catalog for even further consideration. And so we use, and then there's several other pruning steps that happen in memory to further narrow down the information that I'll describe later. I know Pydantic Logfire uses a very similar technique, although they take it one step further. They put significantly more of the metadata into I think they use Postgres too, into a Postgres database, and then they actually will rewrite the predicates that come in for the query into a Postgres query to figure against the metadata that's in there using the same pruning predicate logic, and those are returned. So you can basically do sort of catalog filtering via Postgres. And in fact, it's kind of cool. There's code in DataFusion to convert predicates back into SQL, and they use that, or at least they did the last time I talked to them. And then, this doesn't use data fusion, but it's the same basic idea. The Iceberg REST API is the same story, right? You give it potentially, they call it a plan, which kind of confused me for a while, but you can give it a predicate and it'll give you back a list of files, right? Like it's the same API, same high level API. Okay, so that's catalogs and files, right? So far so good. This has nothing to do with Parquet. Now the next thing I wanted to show that you can do with Data Fusion and Parquet is not just, of course, narrow down which files you care about using some special index, which is hugely important. You need to basically do that, but you can also rule out the interior portions of the file, right? So within individual Parquet files, if you have additional information outside, you can configure the Parquet reader in Data Fusion to select just a subset. So in particular, you can eventually rule out which pages don't match the predicate. You can skip all the work to decode them and fetch them entirely. So again, the picture basically is the same as before, right? You get the query engine gets arbitrary predicates from the user, some arbitrary filter expressions from the query, and then it has to go. You have to use this index structure, which I'm purposely leaving vague because you can be a lot of different things. You use that index structure to quickly find which pages you need to look at for more information. Right? Like that. That's again, this is the picture we're doing, and then we'll show the code that does it in a second. Now, I think most people would, at this point, when they think about Parquet, they would immediately think the only structures you can use to pick which Parquet, like basically the only thing Parquet based systems can use is the information that's already in the Parquet metadata footer, which we talked about earlier, right? So that includes some basic statistics, min-max values for row groups, and in the data pages, potentially if there's this page index thing, you can put Bloom filters in the Parquet file format, but that's about it. So the point is, like, if you have no state and you want to read if you have a stateless engine, right, that doesn't have the ability to store information across queries, and you need to run queries against a pile of Parquet files, yeah, you're going to have to read and parse the footer for each one of the Parquet files. However, if you have state, which basically all non-Parquet based systems do too, you can do a lot more. And so you can basically pre-compute a bunch of information to let you quickly find the location within each file you want to scan. And you can also, by the way, one of the common criticisms leveled against Parquet is that reading the footer tends to be expensive given the encoding format it's in. But again, if you have state and you're willing to build code and add some additional complexity to your system, right, you can easily basically memoize parsing that footer. Right? You don't need to read it off the file each time. You can keep it in memory. You could write it some more efficient local disk file format or whatever. So, and I'll show you how to, and there's an example in Data Fusion to show you how to do that, and I will now show you how to do that. So basically, what I'm trying to say is, I think a lot of people assume that if you're building a system that reads data out of Parquet, it's going to be fundamentally slow because you have to always like decode these footers and then fetch, do multiple object store fetches or whatever. And it's just not true, right? Like you can build systems that don't do that are based on Parquet. Just because a lot of systems that are based on Parquet choose to do that doesn't mean you can't do something better. So this is now from the advanced Parquet index example. Again, I'll leave links to this in the video notes. This shows that there's actually two levels of things you can do with the Data Fusion API. You can specify which row groups within a file you want to read, right? So that you might know something about which one or ones of the row groups you want to use or to skip. And then you can also do that at a lower level with data pages. You actually provide a range, like a logical row offsets, and you can tell Data Fusion to skip or scan contiguous ranges or the Parquet reader. And I think this is important because Data Fusion includes code in here to use the metadata that's already in the Parquet file to prune these row groups and data pages if the corresponding information is in the footer. But you can also provide your own additional auxiliary information to Data Fusion that does not have to be derived at all from the Parquet footer. So let's take a look at how that looks in the example. Again, this is from a code example that's in the repo, that's in the Data Fusion repo that I'll leave in the liner notes. How does it look? Well, like all good places, this is we like to make plans, right? Because we're database people. So what you do is in order to specify the subparts of a Parquet file you want to scan, you create this structure called a Parquet access plan, which has information about which row groups to scan and which ranges. So in this one, we'll start with a plan that doesn't scan any row groups by default. You could also start with one that starts with a row group and you prune out the ones you don't want. And in here, we've used some sort of analysis. We figured out, I don't know, maybe equality predicates, I think the example uses. And here, we have some special index that knows, given the constant value, which row group the row you're looking for is in. And then it'll also be able to, using another index within that, you actually know which row offset within that row group. So you can see here, we tell the plan to scan this particular row group. And then in here, if we know the actual offset, we can actually tell the Parquet plan to not just do that scan, but only scan like sort of this row by skipping a bunch of the rows before and then scanning just one. And what the Parquet reader knows how to do is if the rows prior to this index are in different data pages, it will not fetch the data pages that aren't needed. So that's how it works. And then then you configure the plan. And so what we can see here is that once you have that plan, like that's in each individual file can have a different plan, right? It kind of has to. Each one can have different row groups and stuff. What you do is when you're configuring the reader, there's a way to attach the access plan to the file. And then, I guess I've kind of glossed over before. Like I said, a lot of people will commonly complain about the cost of having to parse the footer for each query. If you happen to have it in memory, which this example does, right? You can just literally provide the Parquet reader the pre-parsed Parquet metadata, right? So in this case, you just basically pass a pointer in, and then it doesn't have to do any IO or any parsing of the footer during the query. And then, like before, we basically just configure the file, scan, and create the data source. This is the same as before. So that's it, right? Like this is pretty cool, I think, in the sense that if you have given the information, right, and I'm not trying to trivialize how much effort it is to build one of these indexes, but if you have to build an index anyway, like that has nothing to do with the particular file format you picked, right? You're going to have to build that structure anyway. And there can be a lot of interesting optimizations and innovation that happen at that level. And then you can basically just feed it into this existing machinery. And again, there's nothing about DataFusion that's makes this possible that you couldn't do in some other system. Other systems can absolutely do this kind of stuff. But oftentimes the ones that have special indexes also have special file formats, and they're all kind of in some tightly integrated system. And so it's much harder to understand that they actually don't have to be connected together. So, my conclusion, hopefully you're a believer, but maybe not, is that you can use Parquet files for basically all analytic performances, including high performance analytics, low latency analytics. And you're not restricted to just the metadata that's built into Parquet. You can use whatever fancy tricks you'd like, as long as then you are able to feed that information into the low-level Parquet reader, which for sure not many systems are set up to let you do. DataFusion is, right, which is why I'm talking about it. But so basically the problem is not Parquet. The problem is allowing people to provide additional indexes on top of Parquet, and I think maybe spreading the word. So anyway, that's and of course, he's part of these talks is always trying to beg and plead for people to come help us make DataFusion better. That's all we got is people who want to work together with us. It's all open source. It's great stuff. We have special indexes. There's lots of other neat stuff that's going on. Help us get the performance back up to the top of the ClickBench leaderboard, for example. We know how to do it. It's just a matter of work. So anyway, come join us. You can find the webpage here. And I hope you enjoyed the talk. Thank you.